Welcome to the Deep Dive. We cut through the noise to give you the essentials, fast. Today we're tackling version control with Git and GitLab, our mission. To really unpack these tools, show how they help teams work together, and honestly, how they save your work. Have you ever, lost hours of work, or just wished you had a kind of undo button, a time machine for your whole project? Well, this deep dive is your shortcut to understanding exactly that.
Right. And at its heart, a version control system, or VCS, is just that. It's a system that logs changes to files over time, so you can recall specific versions later. That time machine idea is pretty spot on. Or think of it like Save As, but way more powerful. And why it's so vital? Well, it tracks history, who changed what, when. It lets people collaborate without, accidentally overwriting each other's stuff. Plus, you can create these independent branches for new features, which is huge for trying things out. And yeah, easily reverting mistakes is a lifesaver. Git itself is what we call a distributed VCS. That means everyone working on the project basically has a full copy of the history right on their own machine. Very robust.
Okay, let's unpack that a bit. When we're talking about Git locally on our own computer, where does all this history actually get stored? What's a repository?
Good question. A repository, or repo, is essentially just the folder for your project that Git is watching. Inside that folder, there's a hidden subdirectory, .git. That .git folder holds all the metadata, the entire history, everything Git needs. Now, platforms like GitLab often call the remote version of this a project, just different terminology for the online container. And the way Git tracks changes locally follows three main stages. First, you have your working directory. These are just your normal project files that you edit. Then there's the staging area, sometimes called the index. Think of it like a waiting room. You use the command git add file to move specific changes here, deciding what you want to save. And finally, the repository itself, that .git directory. When you run git commit, Git takes a permanent snapshot of whatever is in the staging area and stores it in the repo.
Okay, so it's a very deliberate flow. Modify your files, then stage the specific changes you want to keep, and then commit them permanently. So what's the command you'd use most just to see what's going on, to understand which files are modified or staged?
Oh, definitely git status. You'll probably type that more than anything else. It tells you exactly where things stand, what's changed, what's staged, what files Git isn't even tracking yet. Super useful. And one quick but important thing, before you make your first commit, you should tell Git who you are. You use git config global user.name, your name, and git config global user.email, your mail at example.com. That way, every commit is tagged with your info. It's about accountability.
Right. Makes sense. So far, we've mostly talked about Git as this local tool on your machine. Here's where it gets really interesting for teams, I think. What's the difference, fundamentally, between Git and something like GitLab?
Yeah, that's a key distinction. I like the engine versus factory analogy. Git is the core version control tool. It's the engine, mostly a command line program running locally. GitLab, on the other hand, is the whole factory. It's a massive web-based DevOps platform built around Git. It hosts your Git repositories remotely, sure, but it also adds layers of tools for the whole development lifecycle. Things like CI/CD pipelines for automating testing and deployment, issue tracking, collaboration features, code reviews, the works. So to connect your local Git repo to GitLab, you first need to tell Git where that remote factory is. You use git remote add origin URL, where URL is the address GitLab gives you for your project. Origin is just the standard nickname for your main remote. Then to send your local commits up to GitLab, you use git push your origin main. The OU part sets up tracking, making future pushes and pulls simpler. And to get changes down from GitLab, maybe changes a teammate pushed you, use git pull. This actually combines two commands, .git fetch, which grabs the changes, and git merge, which integrates them into your local files.
Okay, that bridges the local and remote. So what does this all mean for actually working with other people on the same project? How does collaboration work smoothly?
Right, collaboration. A really common scenario, especially in open source or larger organizations, involves forking. Forking basically means creating your own personal copy of someone else's project, but within your own GitLab account. This is crucial if you don't have permission to directly push changes to the main project. It lets you experiment, make changes, do whatever you want in your copy without affecting the original. So the standard workflow often looks like this. You fork the main project on GitLab, then you clone your fork down to your local machine using git clone URL. You make your changes locally, modify, stage, commit just like before. Then you push those commits up to your fork on GitLab. Finally, from your fork on GitLab, you create a merge request, sometimes called a pull request on other platforms. This is basically you asking the owner of the original project to review your changes and merge them into their main code base. And if you need to look back through the project's history, locally, GitLog gives you a list of all the commits. And git show commit hash, you get that long hash string from git log, shows the exact changes made in a specific commit.
GitLab also has really nice web interfaces for browsing history, seeing changes visually, comparing versions. Much friendlier sometimes.
Okay, that makes sense for proposing changes, but what about oops moments? We all have them. You commit something, maybe even push it, and then realize, oh no, that was wrong.
Yeah.
How do you undo mistakes safely?
Yes, the oops commands. Very important. You've changed a file but haven't staged it yet using git add. You can just discard those changes with git checkout file name. Boo! Back to how it was after the last commit. If you have staged a file with git add but haven't committed it yet and you change your mind, git reset head file name will unstage it. It moves it back out of the staging area, but your file changes are still there in the working directory. But the really crucial one, especially if you've already pushed a commit that you regret to a shared place like GitLab, is git revert commit hash. What revert does is clever. It doesn't delete the bad commit. Instead, it creates a brand new commit that perfectly undoes the changes introduced by the bad one. This is much safer for shared histories because it doesn't rewrite the past, which can cause major headaches for collaborators. It just adds a new commit saying, okay, let's undo that previous thing.
Got it. So revert is the safe way to undo pushed commits. Okay, let's quickly recap the big takeaways here. Git is your local command line tool for tracking history. GitLab is the online platform built around Git, hosting projects and adding collaboration and DevOps tools. The fundamental local workflow is modify stage .commit. You use Git status to see what's going on. You sync with GitLab using Git push to send changes up and Git pull to bring changes down. Collaboration often involves forking a project, making changes in your fork, and then creating a merge request. And for managing history and fixing mistakes, Git log, Git show, and especially the safe Git revert command are your friends.
Exactly. And connecting this to the bigger picture, it's not just for code, right? Mastering these ideas, tracking changes, collaborating safely, undoing mistakes, it builds resilience and efficiency into almost any kind of project where things evolve over time. Think documents, designs, research.
That's a great point. So think about this. What really stands out to you, listening now, about how these version control ideas could change how you handle a project you're working on, even if it's not software? Imagine applying that time machine concept to your writing or planning or anything iterative. The best way to learn is by doing, so we really encourage you. Set up Git, create a project on GitLab, make some commits, push them, maybe even look into branching or find a small open source project to contribute a tiny fix to. You'll really feel the power and control it gives you.